Hi, this is Deepak. I'll tell you, I already showed you one Fibonacci solution. That is not the most optimized one. There is a lacuna in that. In that, I already mentioned that. That is the Fibo 5. I already told you, right? Fibo 5 through tree structure. How we derived. You cannot see. I'll tell you what is the loophole in that and what is the most optimized solution. I'll tell you all those concepts. What may be the optimized solution. Later, but I'll show you through lead code how it will work basically. Okay. In that concept, I already told you in Fibo. We already mentioned all those base case where it will stop and recursively a function calling itself again and again. Okay, return type Fib of n-1 plus Fib of n-2 basically. In left hand side n-1 all those parts at first it will derive n-1 4 3 2 1, that is it will stop here because it touches the base case basically. In RHS right hand side basically n-2 Fib of 3, Fib of 5 we will get Fib of 3, Fib of 3 we will get Fib of 2. In left hand side we already get Fib of 1 value, Fib of 2 value, Fib of 3 value and all those values we already get it. But despite of that, again if we go to the right hand side again it will derive all those, go to the all child nodes and derive all those values. That is called basically in data structure overlapping subproblem. That is not the optimized one. Again and again it will go to the same value and retrieve it. That is not the optimized one, right? So how we get the optimized one? In that, in the time complexity we already check out all those values, 1 to 4, that is the geometrical progression. How we will put the formula and get the time complexity is big of 2 to the power n and space complexity is big of a. That is one concept. In how we will optimize that one. Basically one concept is there, tabulation concept. I already write the code in whiteboard, but it is not the good way. I will show you directly through write the code through lead code and I will show you. In lead code basically in first code it will TLE time limited something TLE error will be there. We will go to the optimized one and that error will not be shown. That is the obvious way, that is good with compared to the Python. I will show you that one. Before that I will tell you in that concept, optimization concept, that is what I tell, that is memoization. In that we can there is in master we already go through some top down approach, bottom up approach. Basically that memoization is the top down approach. Here we will take an array and all those value whatever it will derive from the left hand side we will put it in that array. When the right hand side required it will retrieve from that. Basically we will go through all those concepts through recursion, right? But it is the dynamic programming concept. I will store that value and whenever required it will derive from that. Basically suppose we will take int array, suppose dp will be there, new int array. That value if we will get the value of 5, then we have to go through the 6 n-1, right? Like that I will loop it from the up to n. Basically if we will go through the concept, how we know that Fib of that particular value we get or not get. Okay, suppose in that we have to looping that suppose that array is dp of 5 is equal to -1. All those linearly we will put 1 up to 5 we will get everything will be -1. If we will get the answer, that answer will be there. Easily we can derive out whether we get the value or not get the value, right? That is the basic things in that. Base case it is also be there. We will take some helper function through that. Easily we can derive. We will pass that array whatever we take and all those whatever that n that dp or n will pass in that and derive all those things easy. That is the memoization concept. Here time complexity basically there we go of 2 to the power n it will reduce to we go of n and space complexity it will be same. That is memoization concept. Multiple solution is there. That is one of the solution. That is I told top down approach. Bottom up approach it is also there. That is called the tabulation concept. Okay, the tabulation concept is like that. We get suppose we go through that. If we get the value of Fib of 5, from that Fib of 5 we will derive all those formula Fib of 5 up to Fib of 0. That is not the optimized one, I think so. We already know the value of Fib of 0 is equal to 0, Fib of 1 is equal to 1, right? In that if we go to the Fib of 5 means no need to, suppose we will create the array and looping it, all those I think scenario already done. In that scenario base case it will be there, but is the return if n, that is the same base case, in less than is equal to 1 return n, that is the 0 1. If it will be there it will return the 0 and 1. Okay, all those things will be same, but one main thing is there, that is the Fib of 0 we already get 0, Fib of 1 we already get 1. And the Fibonacci basic concept is there. Fib of n is equal to Fib of n-1 plus Fib of n-2. If we want to get the Fib of 3, we already get the Fib of 0 already 0. Fib of 1 is equal to 1. For Fib of 3, that previous will be Fib of 2, next previous will be Fib of 1. Through that we already get all those values, right? No need to go to from the Fib of 5, from Fib of 4, Fib of 3, Fib of 2, Fib of 1. We already get the value Fib of 1, Fib of 0. Through that we can previous term, if Fib of 0, Fib of 1 is there, we can easily get the Fib of 2. After that Fib of 3 we easily get from, if we are starting from linearly, our start point will be 0 1, then we easily get it right? That is the basically bottom of dynamic problem, we can call it. That concept is tabulation concept. Here time complexity will be big of n, same, but space complexity, here we also take an array for recursion for diffy array, that is the n, and for recursive stack space n big of n, that is the space complexity around big of n, that is the one. And that is the big of n. From big of n, how can we optimize the space complexity to the big of 1? One concept is also there, how will optimize that one. Bottom of dynamic programming is one there. Through that we can minimize it. Suppose I will tell you a scenario. Every time if we go from fib of 0, fib of 1, that is not the optimized solution, right? If I want to get the value of fib of 999, okay, from there fib of 0, fib of 1 up to the 999, that is not the optimized one, right? We'll go across all those 0, 1, 2, 3 up to 997, 998, 999. That is not the optimized one. For that, how will derive optimized that one? That space complexity will be used in that one. So that we know the Fibonacci concept is there. Whatever that we want to derive, we have to go to the previous and the next previous. We have to add the previous plus next previous. We will get the current one value. Okay. Through that we can easily derive. That is the easiest concept. That base case will be the same. If n less than or equal to 1, return n. If it will 0, 0. If it will 1, 1. Here we will take the second last and derive all those things. That is the optimized. How we can optimize all those concepts. I will vocally I will tell how we will derive all those optimized solution, and I will write it through lead code and put it, and we can easily go through it. Okay, that is the easiest concept. That is easiest means recursion. It may be some problem will be there, but dynamic problem is that is the easiest and optimized one. Dynamic programming space complexity will be 0, time complexity also reduced. All those things will be balanced. Okay, it will also resolve the what is overlapping sub problem. It is also reason. All those things again and again go to the child node and derive the value. That is not good one in real time, right? Thank you. I already mentioned all those concepts. Bye.